Hello, in this video I would like to show you the electronic lab notebook of Sciformation ELN. I will show you how to create, organize and customize your experiments. Let's go to Lab Journal and create new experiment and take a look at this menu here. You may have already watched the introduction video in which I've briefly shown you how you might approach creating a new experiment. However, in this video I will go far more into depth and explain all of the options here in more detail. I would like to begin in the top right here with the experiment type, because this is probably the most important parameter in this entire form, because the experiment type can change the template of the entire experiment. So the simplest template here would be the text template, and this is literally just a text for the procedure and a text for the observation, and that's it. The difference between procedure and observation is just that the procedure will be copied when the reaction is copied, whereas the observation will be discarded. Then there are more complex experiment types for more specialized use cases. For example, the chemical reaction template is very useful in synthetic chemistry, because we can then add reactants, reagents, products and solvents, and those will then also appear in this reaction equation here, so that you can see very quickly what this experiment is all about. And you can then later on use structure or substructure search to find these reactants or reagents, but you can also use, for example, the chemical formula, the Cas number, etc. Moving on, we also have more specialized templates that also make use of this reaction equation. For example, the electrochemistry template also offers options to store potential difference, current and accumulated charge. It also offers some additional calculation options. For example, it will calculate the theoretical duration when you give it a current and accumulated charge that you want to pass through your solution. Similarly, for example, the photochemistry template has an additional parameter for the wavelengths here, as well as for the light source, in which you could add a device from the device database. Or, for example, the autoclave experiment, which also simply has a couple of additional parameters, namely the pressure at the given temperature, and the gas that is used in the autoclave. Then there are more specialized experiment types, such as, for example, flow chemistry, in which you can also add a flow scheme using, for example, like a pump or a continuous stir tank reactor, and then you can link those together to create a scheme for your flow reaction. And there is also, for example, the chemical reaction and workflow. This workflow is basically a way to express a procedure in a machine-readable format, which might be useful in some use cases. For example, instead of writing into the procedure that you add your reactants to your flask, you can just add this process step. Similarly, for example, heating up is also a process step, as well as, for example, purification methods such as distillation or extraction that are also offered as process step types. Furthermore, you can just, for example, choose procedure, which will then allow you to write free text here as a process step. In this tutorial video, I will use the chemical reaction template, since for most synthetic chemists this is the experiment type that's going to be the most commonly used. You can use the paperclip button here in order to save the experiment type as the default for yourself. If we go all the way to the left here, we can see that we can select the lab journal that we want to save the experiment in. And since I am currently demonstrating this using an account which doesn't have very many permissions, we only have permission to write into one lab journal anyway. However, it might happen that you could write into other lab journals as well. In that case, you should select the correct one, and then again you can use the paperclip to set one lab journal as your default lab journal. Next, we can select the project. So it's generally advisable to group all of your experiments to the projects that they belong to in order to keep everything a little bit more organized. So let's click here, and as you can see, I have here already the project tutorial video in my favorites. And again, you can use this paperclip symbol here to add projects to your favorites, or you can use the X to remove them from your favorites again. And then we have also the option to add tags. So these are the default tags that you can use. And you can, for example, say, okay, this is just a starting material synthesis. I'd also like to mention that you can actually click on metadata here. And then you also get some additional options to enter metadata, such as the title, the experiment status, or the person who carries the experiment out and the date at which the experiment started. However, in most cases, you don't need to bother entering anything here. The experiment status will automatically change from planned to completed as soon as you either enter a yield for your product or you attach an analytical data set to the experiment. So for this reason, let's just close the metadata and focus on the part below here. Now there are plenty of options to enter your data into this template. Probably the most intuitive one, if you are used to paper notebooks, is to just write down the reaction equation. And that is absolutely something that we can do here. For example, I can click on the reaction equation here, which is currently empty, and I can just go ahead and draw the reaction. So I will enter the reactants separated by this plus here, then I will draw the arrow, and then I can enter the product. And if I now click on OK, you can see that the starting materials as well as the product will automatically be entered into the corresponding fields. And you can also see that already the lab journal has looked into the chemical inventory and found, okay, this structure is benzaldehyde, and we have this bottle here in this chemical storage. Similar for acetone. There are other ways to enter the data, which I also want to show to you. So I'm going to delete all of this, and I will just show you that you can also press on Add Reactant here. And now there are a couple of ways how you can select the correct substance and container. First of all, you can just click on the structure here, which is currently empty, and you can just draw the structure. And if I draw the benzaldehyde molecule here, it will automatically search the container database for containers which have this structure. And the result here is exactly the same that you also saw when you entered the structure into the reaction equation field before. Let's delete it and click on Add Reactant again. You can also copy and paste the chemical structure from anywhere else in Sciformation ELN. So for example, if you're in the chemical inventory and you see the molecule that you want to use, you can hover your mouse over the structure and press this button here. This will copy the structure, and then you can paste the structure into this structure field here using this button. And you will get the same result as if you had drawn the structure by hand. The next thing I'd like to show you is that you can use this quick search here to simply look, for example, for the substance. So you will get a couple of different options. I will choose the benzaldehyde instead of the derivatives because that's what we need. And again, you get the same result. We can also search for other things in the quick search, for example the Cas number. So if I enter the Cas number of benzaldehyde here, you will get a couple of different results, but those are just the different trivial names of the substance benzaldehyde in our database. And if we click on any of them, we'll get to the same substance. And again, we have the same result as before. We can also select a substance by using one of these buttons here, which give us even more detailed search options. For example, this button here allows you to select a substance from the database. If we click on it, you will get this pop-up window with a very detailed search form where you can look for the substance that we want to use. For example, we can just again do a structure search. And we will get only one result, benzaldehyde. And if we click on this green button here, which is called select, we can select this, and as you can see, the benzaldehyde substance is now logged in, but you still have the drop-down field here to select the correct container if you want. What you can also do is you can use this button here to select a container from the inventory, and here you get a more detailed form to search for a container, not just a substance. And you can use this, for example, to search for a barcode. If you open this group box here, then you get here the field for the container barcode, and here we can then write down the barcode of our benzaldehyde container that we want to use. And when you click on search, we get the container, and again we press the green arrow to select it as our reactant. We can also use the product of the previous experiment as our starting material. For that we can, for example, use this button here, which allows us to search for an experiment. So we will just look for our own lab journal MUO here, and if we click on search, we will get all of the experiments that we've done previously. And we can just select one of them, again with this green button here, and we will get the product of this reaction as our starting material. We can also go to this drop-down menu here and click on reaction mixture. In this case, the structure will not be displayed, and instead we will just get the code of the reaction. An even easier way to do that is usually by just using the quick search. So we can just enter MUO 002 into our quick search and click on the reaction, and we get the same result that I've shown you before. There is also one more thing that you can do here with this quick search, because this is not only a search field, but it can also be used as a normal text field. So if your reactant doesn't have a structure and isn't inventorized, you can simply enter a free text here, let's say something like, and then if you just click away, you can see that the free text will simply be written into the reaction equation instead of a structure. So let's just build our reaction equation. Now that we've added our reactants and our product, let's briefly take a look at reagents, which are similar to reactants, with the key difference that reagents do not show up in the reaction equation. For example, for this aldol reaction here, we still need a base like KOH, and we could add it as a reactant. And in this case you can see that the KOH will show up in the reaction equation. But we could also add the KOH as a reagent. And as you can see, in this case the KOH does not show up in the reaction equation. And however you want to do this is basically up to you. For now, let's just continue with the KOH as a reagent. We also need to add solvents. So in our case, we want to use ethanol and water. And we can add the volumes that we use here. And you can see that these fields here will be automatically populated as well. Let's now take a look at these parameters here. The reference amount is the amount that will be used as the basis for all of the calculations below, and usually you want to use the amount of the limiting starting material here. So if we want to do this aldol condensation in 25 millimole scale, for example, we would enter 25 millimoles here. And then in the chemical reaction template, there is also the field for temperature, in which we can just write 25 degrees, since this reaction will be run at room temperature, and a field for the duration of the reaction, which in our case would be 1.5 hours. And again, you can see that these parameters are automatically added to the reaction equation. I've previously mentioned that all of the calculations below will be based on the reference amount here. However, our reaction here is of course a little bit special, since for each molecule of product we need 2 equivalents of benzaldehyde for each equivalent of acetone. How can we consider this? Well, there is the column of equivalents right here, and we can just write that we use 2 equivalents of benzaldehyde and 1 equivalent of acetone. Since the molecular weight and the density of our starting materials are already known, because they are saved in the substance database of the chemical inventory, all of the other values, such as the mass and the volume that we need to use, are then automatically calculated, so that we know that we need to use 5.1 milliliters of benzaldehyde and 1.84 milliliters of acetone. Now, in the procedure that I have for this reaction, for the potassium hydroxide, it actually just says 15 millimoles of KOH. So in this case, we don't need to calculate the equivalence. We can just enter 15 millimoles into the corresponding column, and you can see that the equivalence will be automatically calculated along with the mass that we need to use. In the case of a solid, of course, the volume doesn't really have any meaning, because this is the density of the solid state material, but we have of course a powder and not a big chunk of KOH that we just can cut out a cube from. So you have to of course be careful. In the case of solids, you don't really want to pay attention to the volume, even though it will be calculated sometimes. Let's briefly scroll down to the product. You can see if I add a product, the equivalence will automatically be set to 1. And in our case, this is correct. There could be some cases, such as cracking of cyclopentadiene, where you might want to put a different amount of equivalence here. So for a dimerization, you might want to put 0.5 here, for example. And as I've shown you before, you can also just write the name of your product in here. So even though this is a search field, you can just write free text. And then if you just click away, then the lab journal will actually save this free text as the substance name for this product, so that we can, for example, later on search for dibenzylene acetone, and we will also find this reaction. We can now copy and paste the procedure into the corresponding field. And there is one more thing that I'd like to show you here, and that is that you can actually reference these components. For example, instead of this whole thing here, we can just write #A, and instead of all of this here, we could write #B, and instead of all of this here, we could write #R1, and these references will later be automatically replaced with the values from this table here. When we are finished entering the data, we can just press on Save and Exit here. As you can see, when we saved the reaction, it gained a reaction number, MUO003, and a couple more tabs have opened here. Most importantly, the tab for analytical data, which I will show to you in a later video in more detail. You can also see now that here on the right side all of the safety information has been copied from the substance database into this reaction. So for example, for acetone we have several MSDSs from multiple suppliers, which if you want you can download. We also have the GHS symbols for each of the reaction components, as well as the H and P sentences here. So now in theory we are ready to go to the lab and perform the experiment, but there is one more thing that I would like to show you here, and that is the option to create a PDF report. For that you click on this button report here. If you click all, you could generate reports for your entire lab journal, but let's just click on current entry here, and this will then generate a PDF report, as you will see in a couple of seconds. And as I've mentioned before, the hash A, hash B, etc. have been replaced, for example here, here, and here, with the correct data from the table of reactants and reagents. With that, I would like to finish this video, and in the next video I will demonstrate the features that you might want to use as soon as you begin the reaction in the lab. See you next time.